hydrogen and hydrate ions. So the hydrogen ion is like the hypoite, ate, perate, consists of adding a hydrogen ion, and it works with a family of anions. So just like the hypoite, ate, and perate has the same charge, has the same base element added to it, you're just doing things, namely changing the number of oxygens that there are. The hydrogen ion is similar to that. So what I'm doing when I'm adding a hydrogen is I'm actually adding the hydrogen plus ion to a polyatomic oxyanion. So for example, I have the phosphate ion, which is PO4, and I add a hydrogen ion to that. So the hydrogen gets added in front, and because I'm adding a +1 charge, the charge decreases by 1. So this would become hydrogen phosphate. I could add 2 hydrogens to this. If I add 2 hydrogens with a +1 charge, the charge decreases by 2 and I add 2 hydrogens to it. So this would become dihydrogen phosphate. So the di tells you how many hydrogens that you've added to it, and every time you add another hydrogen, the base polyatomic ion's charge decreases by 1, becomes more positive. So I can have something like hydrogen carbonate or sodium dihydrogen phosphate here. So I can have it as an ion. So if I had hydrogen carbonate, carbonate has a normal charge of -2. If I add a hydrogen in front of it, this becomes hydrogen carbonate. Because that's a polyatomic ion, I can have it as part of an ionic compound. So I could have something like magnesium hydrogen carbonate, but because the hydrogen carbonate has a -1 charge and magnesium has a +2 charge, I would actually need 2 hydrogen carbonates. The next set is hydrates. So hydrates are ionic compounds that have water molecules that are bonded to them. And the word bond here is really challenging because it's not really a physical bond. It's not really a chemical bond. So we call it a ligand bond, Ligand bond. The water can be driven off by heat and then reabsorbed. So a common example is those silica gel packets that you have with cookies and crackers. There's this little tiny packet that says silica gel, do not eat. So the silica gel in there is an ionic compound that's normally forming a hydrate, and they've driven off the water by heating it up and put it into those packets. And you'll notice that those packets are kind of fibrous on the outside so that they can absorb water. And so they can absorb water if something gets humid or if it gets really, wet inside the packet. The silica gel will actually hold on to the water, and the crackers themselves won't lose their crunch, they won't become stale. So each compound that becomes hydrated has a specific number of water molecules that are attached to it. For example, magnesium sulfate can form a hydrated compound, meaning it has water attached to it, and when it does, exactly seven water molecules attach for every magnesium sulfate unit. So this big dot in between represents the ligand bond, and then the number after that will tell you how many waters are associated with that ionic compound in that ligand bond. So in naming, I named the first part just as I normally do. This is magnesium sulfate. And then I represent the added waters by writing the Greek prefix for the number, 7 is hepta, and then hydrate. So any of these ionic compounds that have water associated with them are hydrated, which helps make sense with the word dehydrated. Dehydrated means that I drive off the water, and oftentimes it's when it's ligand bound to an ionic compound. Not in real life, but definitely in the chemical sense. So you need to learn your Greek prefixes from 1 to 10. So it goes mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So I could have a situation in which I have Cu, SO4, big dot, 5H2O. This would be called copper 2 because it's a transition metal, sulfate, pentahydrate. So now that you've gotten to this point, I could make things really challenging for you and ask you to name something like I don't know if this actually exists, but NaHSO3 dot 4H2O. Now again, I'm completely making up this compound, so don't tell your parents that I said that this compound actually exists, but let's see if we can figure out how to name this. This right here is a ternary compound. The first element is sodium. That part is easy. Not only is it sodium, but sodium is a main group metal, so I don't have to worry about parentheses and Roman numerals. This here looks familiar. Well, for one, it comes from the sulfate family, but it has one fewer oxygen, SO3, 2-, so that would be the sulfite ion. Right, so the ATE gets swapped out for the ITE. And then there's the hydrogen in front of that, which is why this charge gets lowered to just a -1, and it's a 1-to-1 ratio. So this would be sodium hydrogen sulfite, and then I have this ligand bond here, which makes it tetrahydrate. I could add in a transition metal and make you do Roman numerals with parentheses, but that's about as complicated as it gets for now.